here, DID auth, how you do authentication with DIDs, and then verifiable credentials, which is formerly called the Verifiable Claims Working Group at W3C. So what we'll do here is a deep dive into that second one, DKMS. And as Devin finishes getting set up, I'll give you just a little overall background. So DIDs are decentralized cryptographically verifiable identifiers, which means that you don't need any centralized registration authority because you move from that to the use of cryptography to prove your ownership and control. And so it's like this new superpower that's literally going to become available to everyone on the internet. But to harness that superpower, the kryptonite you have to keep under control is those private keys. Okay? And unless there's a really good way to do that, that we all, and I mean all of us on the internet can do, it's not going to, save the world. To stick with the Marvel analogy here. So sometimes the way I describe it, you think of the big iceberg of self-sovereign identity. DID is a little tip above. The key management is the big problem. And you've heard all the discussions of wallets yesterday. This is fantastic. So we're going to be actually running 2 key management sessions here in this room, back to back. This one's going to be on DKMS, which is this open standard that we're proposing. What you're going to see is a demonstration of the design and architecture for DKMS that we just published, and I just got finished sending an email to Anil John at DHS. The docs we're publishing on the design and architecture, it's about a 64-page document, is going to the Hyperledger Indy repo on GitHub. But it turns out the procedures you have to go through to get something on Indy take longer. So in order to have it publicly published today, we published it at the Sovrin Foundation repo, which is publicly available. So the tweets going out right now are to the Sovrin Foundation, the link to the Sovrin Foundation repo. I think it'll be in the notes. We'll tweet it out some more. But Anil immediately went, wait a minute, you said it's going to Hyperledger Indy. And I said, yeah, it is, but it turns out there's a bunch of hoops you got to go through to get a new repo there. So currently, for the next couple of days until we get it there, it's at Sovrin Foundation. So we can put up the link later on today. What we did last week, at the conclusion of this, again, 1-year contract we have with DHS, was give a demo of the prototype code doing all the things that we're going to describe in the architecture for DKMS. So we have all of this working. Not all of it is open source. Currently, a number of the components, the Hyperledger Indy library that Devin will be talking about, that is at Hyperledger Indy, which is a project at Hyperledger, which is hosted by the Linux Foundation. So it's all under Apache 2 license, all open source. The whole document that we published is an open public document. DHS paid for it. There's a thank you to them in there, but there's no proprietary rights in any of it, and it's planned to go to an open standard organization, most likely OASIS. I don't know if you're familiar with OASIS, but they're currently the home of something called KMIP, the Key Management Interoperability Protocol, which is basically how enterprises can manage keys for potentially thousands of applications via a centralized key management server, and how they can do that in an open standard way so that enterprises are not locked into vendor-specific solutions. DKMS is basically the decentralized equivalent of that. How can we all have wallets? How can we all manage keys in a way where you're not locked into a wallet vendor? Hey, John, how are you?
I want to be locked into a wallet vendor.
I want one of those little new beards.
It takes time.
Yeah.
Be patient.
It grows on you.
All right, so what we're going to show you is the exact same demo that we gave to Neil John and his team at DHS as our sort of final report, our doctoral defense. And it's intended, so go ahead. There'll be a little bit of background. This is the team. And then we're going to show you architecture. There are 5 chapters of the demo. We're going to show you what's happening in each chapter conceptually. We'll show you UI elements that were developed to do it. They're not all plumbed up, but the idea is there's a web UI that will all be available by the open source code. And then we're going to show you the code. Devin is going to run the CLI and walk you through what is happening. Now, at that level, this is really for the developers. If you're just here to see the overall picture, you'll get it, but we intend to go as far deep into the weeds as you want. So go ahead. Oh, there's also going to be a 5-minute video explaining DKMS. I did the narration for that a couple weeks ago, but it's not. We're doing the animations right now, so it's not quite ready yet. This is the one-slide summary of what the whole project was about, and it's super important. Usability is a major factor here. You're going to see a little bit of it in the UX elements here, but one of our subcontractors in this project was BYU's Internet Security Research Lab. They specialize in security usability. And it's not part of what we're doing here today, but they did some fascinating tests, some surveys, and then some usability tests around key recovery. If there's time, maybe we'll do another session about that tomorrow. We can show you some of those results. But we'll just get going with the actual demo today. Let's go on. Okay, yeah, so anyway, the document that's published it's again available starting this morning at the Sovrin repo, and it will go to Hyperledger as soon as possible. Has the whole protocol design, and there's 17 sequence diagrams for all the different elements of the protocol stuff. It is ledger independent. You can use it with any set of DIDs that can support the different protocol functions. And yeah, blah, blah, blah. Okay. Forget the video, and we go right into the demo. And we don't have Devin was the what we call the mission commander of the DKMS team at Eveenym, where there were 4 engineers on the team.
Yeah.
Yeah. So as you get to the deep tech questions, fire away. So we're going to do this in 5 chapters in this demo. The first 3 show how Alice is going to create connections. The first one is actually going to be to an institution. We love the credit union, so it's just officially C Union. Then she's going to do a peer-to-peer connection and share a verifiable claim with Bob. And third, we're going to show how you use DKMS with vehicles, with things, like cars. And then we're going to go in and she's going to set up, so DKMS supports offline recovery using, paper wallet or some safe place you store a recovery key. But then it's also supports social recovery, and the latter one uses much more of the protocol. So we're going to go through how she sets up 3 trustees, and then we're actually going to show what happens when her phone is stolen. She doesn't just lose it, it's stolen, so it needs to be revoked, and she's going to do recovery from 2 out of the 3 trustees. That's her policy. So those are 5 chapters we're going to go through. For each one, we will step through big picture, show you the UX artifacts, and then spend the majority of the time actually showing you the CLI demo. All right, any questions before we get started? Let's dive into it. All right, we're going to start out with Alice. And now what we do here is show this agency space. That's for the cloud agents. There are 2 types of agents, DKMS edge agents that work on the edge devices, and then cloud agents that work in some agency is the term we use for it. Agencies are they're going to be commercial providers, just like there are for email or websites today. It's just a new type of service provider. You can also, of course, run your own, just like you run your own email server or web server. So what we're going to show here is we've got a credit union here that's got a cloud agent. Cloud agents have cloud wallets, edge agents have edge wallets. That's our symbol for those. And we're going to blow up a picture of a part of what's going on in C Union's wallet. And we're going to, a lot of folks that want to, in the 101 sessions, I reinforced that DIDs, you think about social security numbers, telephone numbers, you get one, you have one, right? That's yours and that's your identity. Well, as we move into self-sovereign identity, you have DIDs, they're always for relationships, right? You don't have just one, they represent relationships. So the adoption of self-sovereign identity is actually one of being introduced by someone who's using it to the world of self-sovereign identity through a DKMS interaction, if we're right about this open standard. Which means, and this is what we're working on, I said we, Eveenym and the Sovrin Foundation, working with the credit unions, what we're going to show here is exactly what they're actually currently starting to work on, a trust framework and an implementation architecture for. Give you a rough sense, John Best is going to run a session on this, and might even be right now. They want to get this into production by the end of this year. They want credit unions issuing a new credential for credit union membership. I see Devon's going, it is going to be a little tight. But anyway, they want credit unions to be issuing a new credential for credit union membership called MyCUID. And any credit union in the world that says, oh yeah, I'm going to sign up for that trust fund is going to be able to start issuing that to their members. They will literally turn around and say, hey, we can give you that credential, go get a digital wallet from one of however many vendors actually support that wallet, and they will start to be able to use that credential immediately with their credit union and with any other credit union. That's the point of this new trust fund. So this is not a hypothetical scenario. All right, so we got this first step. They're preparing for a relationship. They've created a key pair and a DID. Now this is Sovrin specific. What we're going to show you here is based on the Sovrin. So the DID is actually the first half of your public key when you create that key pair. So it's generated right there in the wallet, and they already know what the DID is going to be, and they generate a QR code that is going to be an invitation to Alice to form this connection with them. All right. One way or another, they get that QR code to Alice. The easy way to think about it is you enroll by going to a credit union, and they say, great, get this app. You can even, of course, do it right there in the credit union, and you scan that QR code, and you're forming connection with that credit union. All right, keep going. When Alice gets that app, what it does is it immediately she installs that app, creates the wallet. The wallet turns around and will register a cloud agent. And now, when she scans that QR code, it creates her half of that pairwise connection. Again, all that inside the wallet, it generates a key pair, and the first half of that key pair with proper encoding becomes the DID. And now they're going to, because this one also had the address, the two cloud agents talk to each other. They form what we call a connection. What they have now done is the classic thing of each of them has exchanged the DID, which has the associated DID document, the public key in both directions. They have a private, pseudonymous, pairwise connection with that key exchange.
Clarification. So Alice already had an identity, or is
No,
she
she doesn't have
creating
anything
it
so far.
She just has a blank wallet, and
She
started
started with a blank,
from scratch.
Started from scratch. Yeah, that's the thing of starting with someone's introducing you, basically. You're going to get an invitation from someone. It can be a person, it can be an organization, it could actually be a thing, right? You could buy a car that says, you can use, DKMS or, Sovrin or something to unlock your car. Go get an app and scan. We'll show that in the third one. Go ahead.
I'm assuming that the credit union did the know your customer dance before they gave the QR code.
Yes, that's a good point. If we're talking about a MyCUID credential here, yes, they would have done that separately. That's part of the reason.
Anybody who's going to invite you to make a connection has to know who you are in some sense. With a credit union, it's a much more formal legal sense.
Yes. Put it this way. Any relationship you form and the set of credentials you'll exchange is contextually dependent. Right? You want a driver's license? You're going to have to go do what the driver's license authority requires. You want a credit union membership card? If Devin and I literally want to, and this is one of the DKMS things that we want to do QR codes at a party, right? Bingo, it's peer-to-peer, right? And we decide we're going to show a business card exchange.
So one concept is that the connection isn't trust, right? So like, for the C union, they could create connections at pretty low risk. Like when they go to actually issue, what would you call it?
The MyCUID credential.
Yeah, that credential. That's when they should have done a fair amount of checking of that.
Yeah, this actually is really important. Think of it as a little bit, to use a protocol analogy, create TCP/IP connection. You're just connecting these two IP addresses, right? Then you say, okay, well now, what's the website at the other end? Does it have a SSL certificate, right? You work your way up to higher levels of trust. What we've done here is just created a DKMS key exchange. Now, we're actually going to go through, that's the next thing, right? We're going to show what we're going to show here, and you're going to see in the code, C Union is now going to offer that credit union membership. Now this is assuming that's actually one of their members. It's past the various steps. They're going to offer over that connection that credential to Alice. And this is using the protocol to send over what's called a claim offer, excuse me, a credential offer. Alice is gonna get that and say, yes, I want that credential. And what's the last one? Oh, that's the end of that one. Okay. She gets it. She basically has to say, yes, I want the credential, and then it goes into her wallet. Okay. Now there's one more step that we'll show here at the end of this, which is DID off, which is Alice now calls up the credit union and says, hey, I need some customer service. They can A, ask her 20 questions, or B, if she's enrolled, they can ping her phone with a DID off challenge. She can do a Face ID or Touch ID, and she's in. And we will show that at the very end of this chapter. Okay? That's what we're going to show. We're going to stay to get through all 5 chapters. We're going to keep going. All right, so quickly, some UX artifacts. These are web UI things here you're seeing. Again, we're not going to show the mobile phone experience on this, but you can see that demo during demo hour. This is C Union generating that QR code. Now we're switching over to Alice. Again, if Alice had a web UI, she's adding a connection. She's scanning that QR code. Does she want the connection with C Union? Yes. And now she's got a new connection. We're going back over to the other side now. C Union is going to say, okay, we want to offer a specific type of, it still says claim here, specific type of credential. They're choosing the one they want to offer her is an account certificate. They hit to send the claim offer, and it's acknowledged on their end. Back over on Alice's side, she would receive a claim offer. She looks at it. She says, yeah, that's my account. She decides to accept it. It moves from pending into confirmed. And now, over to Devin.
All right, so we're going to run through a little demo. Each of these console windows represents an independent agent. They're running as their own process. And outside of the bootstrapping of the connection, which is going to happen over just a simple file drop where one drops a file, the other one reads it. All the rest of it is over a secure channel through a cloud agent, and they're all completely independent.
Right, so the edge agents are talking to the cloud agents that are talking directly to each other.
And before we started this first chapter, we've done a little bit of initialization for Alice. We've put on the ledger her policy authorizing this particular agent to act on her behalf, and that will be used throughout the demo, and then towards the end we'll see that authorization being revoked. So go ahead and start.
So by that, for DKMS, not only there are DIDs, there's what's called authorization policies, registries. So as Alice adopts devices, a key pair is put up, the public key is put up. She's basically authorizing the device, and every time she uses that device to share a credential, she's providing a proof that that's an authorized device. At the end, you'll see that she's going to revoke the device because it was stolen, and now she can no longer give those.
We won't go enough detail to actually show it, but it's all blinded and it's using zero knowledge proof. So she won't, when she proves these things, she won't be showing that key. But she'll be offering proof that she is part of a set that has been authorized.
Right, so you can't go to the Sovrin ledger and look and see, hey, there's any one person's devices and what's been authorized or not. But they can produce proofs of an authorized device as long as it's still authorized.
We're going to send her an invitation. She'll get it on her end and accept it. Union now this is the certificate that they want to send, the credential that they're going to send to her, and Alice receives the offer here and can look at it and be like, is this account the right number, or maybe the name is the right thing, and when she replies to this, she's going to add a few blinded attributes. One is a link secret that's going to tie the credential to her identity, and then also there'll be a policy address that is also blinded, but will also tie this credential to that particular policy address that is part of her identity. So she can accept that. And then C Union is going to decide whether they want to finalize and actually sign it, because what they sent previously was just like a preview of what they were going to do with the credentials. Now they'll actually bind it to themselves so that she can later produce proof that it actually came from.
Right, so C Union sends a claim offer, Alice has to say, yes, I want it. When she responds that way, then they produce the encrypted credential using her leak secret and give it back to her. Now again, if you want to see the real commercial end user experience of that, the Eveenym VCX demo will show you what that looks like in a commercial product. It's very similar for other products like U-ports. Go ahead.
All right, so now they're just doing a quick did off.
So this is the did off now.
This is the real prototype did off. They're just doing a quick nonce challenge.
Right, so C Union is literally sending a message over that connection to Alice, and all it's got is a nonce in it saying, sign that and send it back. And we know your public key, we can verify that.
So that's the end of that first chapter.
Okay.
So the authentication for the app itself.
What you're doing is you're authenticating the connection. Now that's a level of assurance that, you know, it's up to the verifier. It's now sort of becomes a continuum, as in a verifier at any one point in time can say, well, what are the credentials I actually want? Including, do I want a biometric credential? So biometrics now start to fit into a protocol flow that's much more flexible than...
Can you hack the app and somehow the app then...
If you can hack the app such that you can control those private keys, yeah, the attacker is going to do real damage. So that's why you want the app. Ideally, you want the keys in a secure element on the device, and you know, lock it down as far as we get. There's no perfect solution to this stuff. I'm not a deep expert in that aspect. I just know I've talked to security architects all the time, and they're down to it. And I just want to remind everyone, okay, now we're into attackers having to attack and break into the secure element on your devices versus spoofing your password at a website. I think we're going to be in a little bit better position here, okay? Yeah. All right, chapter 2. Now we're going to show a peer-to-peer connection between Alice and Bob. It's very similar to what we did in the first one. Okay, you really flew through that. Could you back up a minute and let me just talk through it? Okay, so Alice is literally, in this case, this is the scenario of the face-to-face coffee shop, right? Alice is going to produce a QR code for a key pair on her device. She's going to give it to Bob. Again, you can just directly, he scans it on his phone, and bingo, their two cloud agents are connected. Now, any way you can move the information of that QR code between the two of them, it could be behind a link in a text, you come to a blog, you can do it face-to-face, you can do it via an NFC connection or a Bluetooth connection. There's nothing that's specific to the transport protocol. You just have to get the information about the key pair, the DID that is going to allow the two agents to get connected. Go ahead. Yeah.
Yeah, so the role of the agency in this case, is it just creating the service endpoints? Or...
They're creating the service endpoints and hosting those edge agents.
Okay.
Because the edge agents in these scenarios don't have any keys, all they're really doing is message routing and storage of the cloud wallets. Of the encrypted wallets that we'll get to in the last part. Go ahead, Dan. Yes. What really,
And it's part of the invitation too.
yeah. The DID that Alice is offering is in that invitation, that connection offer. Right. Okay, so that's right. Then Alice is actually going to offer, so you think verifiable credentials, they're not always just driver's license from issuers. A business card exchange is now a verifiable credential. Okay? Alice is going to offer up a very simple business card to Bob, and Bob's going to say, yeah, I want it. Okay? And before Kalia jumps up and down and goes, Facebook distributed!
I won't do that. Okay, Drummond.
Yeah, she would do that. We will get there. Just one step at a time. Okay.
Alright, so the beginning of this is going to have a very similar feel to the previous one. They're just going to exchange a connection very similarly.
It's very similar. I mean, the fact that it's peer-to-peer between two people, and the previous one was a credit union, it's really.
Alright, so
here's the
proof request. So he's going to request, these three fields: name, email, business, and all he's requiring from her is that it comply with a certain schema on the ledger.
right. Now, before you go on, this is an important point for all the data semantics people in the room. On Sovrin, when you are the credentials that you want to offer or request use claims, attributes from schemas that are also published on Sovrin. The address is what's called a schema sequence number. So anyone can publish a schema and then create what we call claim definitions based on that schema. Any claim definition can use any element from any schema. So what we hope happens here is you start to tackle some of these hard problems of data interoperability by just having different issuers and verifiers go, hey, look, this is what we really need to be exchanging. Yeah, it'll be fairly simple at first, but we have an evolutionary path, a more complex schema over time, but a common way to triangulate on really solid definitions.
And we're going to show selected disclosure because the schema here actually has a number of other fields like phone number and other things that Bob is not asking for. And when we get over to Alice, she will not provide.
Right, so Bob is asking for these things. Alice has more information, but she is going to provide back what she's going to be sharing with Bob is a proof of just those things.
So are those public? It's like a public schema.org type.
Yeah.
That you can just look up.
Think of it as the ledger equivalent of schema.org. Yeah. That's a pretty extreme. Go ahead, John.
So the agency here is a provider of the service that's making these endpoints connect.
Yeah, it's hosting those
Right.
agents.
So Alice and Bob already had to have been part of that agency?
Yeah, like in that first step, Alice got the app and registered with some agency.
Right, but like in the coffee shop, we have to find a common provider?
No. That's the whole point of the protocol is, it's like email in that sense, right? I got an email account, you got an email account, right? It literally is,
Okay.
yeah. And that's, now
Because
again,
of two
the
different
interoperability
agencies.
at that layer is going to be, if you have a Sovrin did and Ruben has a Uport did, okay? The interop we want doesn't matter. You can talk just like you had two different email domains. That's why we're here at this conference, to work all those things out. Okay, ready to keep going?
All right, yeah, so these are what was requested. She's going to send the proof, so she's going to generate it. And this proof is going to include a zero-knowledge proof with disclosure of those three fields, even though there was 5 fields in total. It's going to also include a proof that the agent that is being used here is part of the same address agent policy that's on the ledger, and that's also going to be a zero-knowledge proof.
So there are 2 proofs being presented from Alice and Bob, okay? Here's a proof of my business card, the things you asked for, and here's a proof that the device you're receiving this from is authorized.
So here's the proof that came over. Well, this is the human readable portion of it. So it shows some things about who the issuer DID was, the name, the value. So she was, for her business, she was the LLC group. Her name is Alice Smith. Here's her email address, and these were revealed attributes. So
That's a really important point. Often people ask, well, you're using zero-knowledge cryptography. What about the data, right? What if I actually need the data? Think of what you can do with a zero-knowledge proof is a superset of what you can do by just ordinary data exchange or encrypted data exchange, right? You can do all that. You can review all the data if that's what you choose to do. But you can also do anything, any subset of attributes, and then proofs, predicate proofs against attribute types. Like for birthday, you can prove over 100. Go ahead.